on quantitative reasoning, and reason being that we are the math team, and that's our main focus. And we know how important it is to develop quantitative reasoning, and so we want to help you in that category. So let's look at quantitative reasoning. What does that entail? So there are 6 categories for your quantitative reasoning. You are sometimes given a pattern and asked to complete that pattern, or maybe you're given a problem, and from that problem you yourself can identify a pattern and use it as a strategy to solve. There is also an area where you're asked to represent quantities. Most times, math is all about quantities. And so you want to be able to represent those. Another category is comparing quantities. And we test your ability to solve problems. All the categories are underlying elements of problem solving. Also, there are times you're just asked not to just give an answer, but you're asked to use approximation or estimation to arrive at the answer. And finally, you are going to be asked to do some form of data analysis. So all the skills that you have been learning throughout your primary school years are coming into play here in the PEP ability test. But no need to worry, because we are here to help you this afternoon develop these skills in quantitative reasoning. So again, we're looking at developing quantitative reasoning. And how do we go about doing that? We're going to be sharing a few processes here with you. One of the first things you want to do when you are given any paper or any question is to read the instructions carefully. And why do we read the instructions carefully? You want to know what you're asked to do, and you want to do the right thing. Then you move on to reading the problem. Now, just reading the problem takes in so many things. You need to read the problem so you understand what it is saying, and you can be familiar with the information that is given. Having done that, then you'll be able to determine the math that is necessary to complete the problem, and just go right ahead and do the math. And by the way, it's based on your understanding of a problem that will determine the pathway that you would use to arrive at the answer. And finally, after doing any math question, you want to check your answer to see how reasonable it is based on what you were asked to do. So we're going to be doing all of that this afternoon. So for today's session, you will be given some problems. And as you're given these problems, we're going to be focusing mainly on the process, how you process the information that is there, how you process the problem to arrive at as a math, yes, a math idea, a math strategy to solve the problem and get to the solution. So the solution is the last thing that we'll look at. A lot of time will be spent on the process. So let's get started. So let's look at question 1. And question 1 reads, imagine some colored blocks are laid out in a row. 4 red, 1 blue, 4 red, 1 blue, and so on. If there are 105 colored blocks, how many would be red? Look at this question. You want to ask yourself the question, what do I know from the problem? And so as a part of our quantitative reasoning, I want to encourage you children to always pick out the information that's given in the problem. I wonder if you could type in the chat, what are some information given in this problem? So go right ahead and type it in the chat. What information is given? Very good, Tamia Richards. Let's type all the information that's given. Awesome. Awesome. And they are coming in. Thank you for sharing. So persons have typed in the chat that there are 4 red and 1 blue block. 4 red blocks, 1 blue blocks. And what do we call this? I wonder if anybody could tell me what you call this. 4 red, 1 blue. 4 red, 1 blue, and so on. What do we see happening here? Awesome. We see that there is a pattern. And boys and girls, remember, we're looking at the process here. So you have observed that there is a pattern. And can we use this pattern to solve for the answer? So let's look now. We are going to look at the math that is needed to solve the problem. So here we have it. The pattern is 4 red, 1 blue. And so we want to use this to help us. How can we use this pattern to arrive at 105 colored blocks and at the same time determine how many of these blocks are red blocks? I believe that this pattern will help us. But before we go to that, we could write this pattern using ratio. I'm sure you have done ratio before. And so to determine the ratio of red blocks to blue blocks, we could look at the number of red blocks and the number of blue blocks. So there we have it, 4 red blocks to 1 blue block. And we can write this into as a fraction. I wonder if anybody could tell me what would be the fraction for the red blocks? Yes, so what would be the fraction for the red blocks? You could write it in the chat. Okay, and the answer is coming in rapidly. Oh, awesome. And I have it there that the fraction would be 4/5 of the blocks are red. And so you want to take in the total number of blocks to get how many blocks are there. And then we use the number of red blocks out of the total number, which is 4/5. And there we have it, 1/5 of the blocks are blue. So if we use this pattern, 4 red, 1 blue, how could we arrive at the answer to determine how many red blocks are there? Boys and girls, I'm going to share one strategy here that you could use. You could actually use a table to represent this information. So look on the table that is shown. On this table, we have a column for the number of red blocks, another column for the number of blue blocks, and the total. So I want you to notice, for every time we have 4 red blocks, there is 1 blue block. And that's shown there in our diagram. 4 red blocks and 1 blue, and the total is 5, which would take in the first series of our pattern. And then let's look at the second one, which is this set here. Again, another 4 red blocks. And so what we would do is now add that to the 4 that was there. So here we have it, 8 red blocks, 2 blue blocks, giving us a total of 10 blocks. I wonder if you could tell me what would happen when we have 3 blue blocks. How many red blocks would be there? And what would be our total blocks? Write it in the chat. Okay, so I'm seeing the total, beautiful. Okay, so I see the number of red blocks. What about the total blocks? Put that in also. Awesome, and the chat is just burning up. And most persons said we would have 12 red blocks. Let's see. So we're going to continue the pattern and put, so there is 1 blue added. So we will have 4 red blocks added. So there we have it. It would be 12 red blocks and 3 blue blocks, giving us a total of 15 blocks. Awesome. I wonder who could tell me what would be in the next row for the red blocks. So type that in the chat, the 3 numbers. 1 for the red, 1 for the blue, and the total. Separate each with a comma. Let's see. All right. Awesome. I see that. 16 red blocks, 4 blue, and the total is 20. Awesome. Beautiful. So there we have it. So boys and girls, what am I pointing out here to you? If you can identify the pattern in a problem, you can arrive at the answer by using that pattern. But we are just at 20 blocks. And remember, it's a total of 105 blocks. And so as grade 6 students, I don't expect you to just be adding to the table 4 red blocks each time and 5 and waiting until you get to 105. We can use a more efficient way of getting to the answer. And one way to do that is actually breaking down 105 into a smaller number or smaller numbers that you can handle, all right? So let's say, suppose we break it down into 100 plus 5. Here we go. We could account for this 5 by saying, this is the pattern for 5 blocks, 4 red and 1 blue. So that is already taken care of. So now we have the 100 to take care of. And with that in mind, we could go to our table and see what we could use there, which of the pattern we could use there to help us break down the number here, yes, break it down, and also to decide how many would be red, how many would be blue. And so, boys and girls, I look at the second set of number here, 8 red blocks, 2 blue blocks, and a total of 10. And you could use any one you want to use. All right, but I choose this because one of the reasons why, because it's so easy to count by 10. It's also easy to count by 5 and by 20. So it depends on which one is easier for you. And so I can see here that there's a relationship between 10 and 100. So for every 10 blocks, I notice that there are 8 red blocks and 2 blue blocks. And from that, I can say how many sets of 10 can I get out of the 100, which would now leave me with 10. That would make 10 sets. So if I have 10 sets of 10, it would be 10 sets of 2s and 10 sets of 8. And that would help me to arrive at my answer quickly. Okay, so here we go now for the 100 blocks. When we have 100 pattern blocks, there are colored blocks here, we are seeing that 8 multiplied by 10 would now give us 80. So we are seeing that 80 of the 100 blocks are red blocks. And then 2 multiplied by 10 gives us 20. So 20 of the 100 blocks now give us 20 of the 100 blocks are blue blocks. And that would give us the total of 100. And so boys and girls, using the pattern, you could have completed the table as well as arrive at how many. So we are seeing 80 here. So you now want to take this 80 with this 4 red blocks here, because we have to take into consideration we're working with 100 and we're working with 5, because we've parted the number 105 into 2 smaller numbers that is easy to work with. So I would now take that 4 red blocks and add it to the 80, which would give us 84. And for the blue blocks, it would be 20 added to 1, making it 21. All right, so let's look at that. Another way, the fact that we wrote the number as a fraction, or the number of red blocks to blue blocks as a fraction, you could actually use that strategy to help you arrive at the answer. And quite efficient, 4/5 of the 105, and that would result in 4 multiplied by 21, you're giving us 84 blocks are red. So boys and girls, any of those strategies could work. And I know if I ask other persons in the chat, if you have another method or another strategy that you could use to arrive at the answer, you would tell me yes. So remember now, quantitative reasoning is based on your understanding of the problem and how you use the information given to arrive at the answer. All right, so right there we have the answer shown for you, that 84 of the blocks are red blocks. Now that was question 1, and that was a bit of reasoning. Yes, we had to reason with the information given and with the quantity given there. So here is another problem for us. A baby giraffe was born standing 150 centimeters tall. It grew at a rate of 30 centimeters per day. Suppose the baby giraffe continued to grow at this rate. How many days old would it be when it was 600 centimeters tall? And as I would ask you, look at the information that is given. So I want you to tell me, what are the information given in this problem? Okay, I see the answer coming in the chat. Yes, answers are coming in. Savvy is saying that the baby giraffe grows at 30 centimeters per day. Awesome. And Kamea is saying that the baby giraffe was 150 centimeters at birth. Awesome. I see all of that coming in. And the most popular one is that the baby giraffe grows at 30 centimeters. Awesome. Per day. Now, there's another bit of information. Now, how are we going to use this information to solve the problem? So here's another bit of information that I didn't see much of, that its new height is 600 centimeters. So these are things you want to take into consideration. The baby giraffe was 150 centimeters tall at birth. Very, very important. And it grew at a rate of 30 centimeters per day. And then we learned that it has a new height of 600 centimeters. How many days did it get, or did it take for the giraffe to get there? What math are we going to use to find that out? Wow. So like the previous question, we could also use a table to help us arrive at the answer. So boys and girls, this is a powerful strategy that I'm sharing with you. Once you are given information in a problem, if you can represent that information on a table, on a number line, on a diagram, any diagram at all, that can actually help you to arrive at the answer. So that's a strategy I want you to take away from this. If you can represent information using a table, use it. And then while you use a table, you can look for patterns and relationships that would actually help you to use a more efficient way to arrive at the answer. So I want to ask a couple questions here. So here is a table. If you're going, but you have to know what to put in on the table. That's very, very important. The height of the baby giraffe, which is 150 centimeters, need to be there on the table. That's the first thing. Also, the fact that they're asking how many days did it take for the giraffe to grow to 600 centimeters, you want to include number of days. So I want to ask a question. So that's there. We have height in centimeters, and we have number of days. And the first number of day we have there is at birth. I want persons to tell me if I'm going to number that day, what number would it be? Go right ahead and type it in the chat where we have at birth. At birth, what number would that be? Okay, Maddie says 0 day. Jaisiana says 1 day. Oh my, let us check and see. Okay, and I see quite a few answers coming in there. So let's look at it. 150 centimeters at birth is actually the number we are starting with. So I would call that our starting point in math. And for math, if we're using a number line, if we look on a ruler, what is usually the starting point? If we are starting at the lowest, it would be 0, as some person said. So if you said 0, come on, give yourself a clap. Yes, you deserve a clap for that. Excellent. And so we want to use this pattern and the information give us to help us. So let's say we're putting in for 5 days. How tall the giraffe grew. On day 1, can anybody type in the chat? How tall would the giraffe be if it grew at a pace of or at a rate of 30 centimeters? 30 centimeters. Awesome. I see the answers. Lemar Lemon. Awesome. Jessica. Trishana. 180. Excellent. Beautiful, beautiful. I see the answers coming in. So there we have it. So children, we have to use the information given in the problem to help us arrive at the answer here. Here we know that for day 1, the giraffe would grow another 30 centimeters. So what we would do is add that 30 centimeters to the 150 centimeters. That's already the height or the starting height of the giraffe. So there we have it, 180 centimeters. That's day 1. Day 2, we could continue this pattern by adding 30 centimeters. So another day he would grow 30 centimeters. So 180 added to 30 is 210. And for the 3rd day, another 30 centimeters would have been added, or he would have grown another 30 centimeters. And when we add 30 centimeters to 210, we get 240 centimeters. And we could do this all the way and work our way until we get to our 600 centimeters. So let's look at this. So day 4, the giraffe has grown all of 270 centimeters. And for day 5, we add another 30 centimeters, and that would take the baby giraffe to 300 centimeters. And so as my grade 6 students would say to me, Miss, with such little time in the exam, do I have time to keep adding 1 day at a time? And I would say it depends on how fast or quickly you work. Or my other solution to that is, as grade 6 students, let's choose numbers that you can work with easily. And that was pointed out in the table before with the number of red blocks and blue blocks. Here we are seeing 5 days, that over 5 days, the baby giraffe has grown a set of 30 centimeters, 5 times. Yes, 5 sets of 30 centimeters. That's 1, that's 2, that's 3, 4, and 5. So that's 5 sets of 30 centimeters over a 5-day period. And so to work a little bit more efficient, I would say, how many does that add up to? What's the total? So for 5 days, I am seeing that 5 days, the giraffe would have grown a total of 150 centimeters. So for every 5 days, just like we're saying, for each day, the giraffe grows 30 centimeters. I could now say for every 5 days, the giraffe grows 150 centimeters. So I am adding bigger numbers, I'm making bigger jumps, and I will arrive at the 600 centimeters quickly. And so grade 6 students, we want you to be reasoning, yes, quantitatively with the numbers to see how you can now work them in your way to work with a more efficient method and to arrive at your solution a little quicker. So let's say we're going to use the 5 days now. We're going to add another 5 days to the 5 days that's here. And that's why I have a break here, because I'm going to move on from adding 1 day at a time to adding 5 days. Add 5 days to 5 days here, and that gives us 10 days. And so for that, I am thinking back that for 5 days, it's 150 centimeters that the baby giraffe grows. So I want to now add that 150 centimeters to the 300 centimeters. And that would give me 450 centimeters. And look at what is happening here. My goodness. After adding another 5 days, I arrive at 15 days. And for 15 days, the giraffe has grown, yes, but that's another 5 days. The giraffe has grown 150 centimeters, which I will now add to the 450 centimeters, and that will give me 600. So there and then, I have arrived at the answer quickly by moving from 1 day or adding 1 day at a time, which is 30 centimeters per day, to 5 days interval, which is now adding 150 centimeters. All right, so here we go. And as a matter of fact, remember I said to you that you can use various strategies or methods to arrive at your answer. So I'm going to share a second strategy that you can use to arrive at your answer. You could actually use a number line to represent the information that's given. So remember, always include the information that is given. That's what you're going to use to arrive at your answer. So you want to look at what was given. Here we know that at birth, the baby giraffe was 150 centimeters. And that now we're checking to see how many days it took the giraffe to get to 600 centimeters. Oh, awesome. So here is our starting point at birth, 150 centimeters, and our end point is 600 centimeters. One of the things you want to ask yourself here, children, is what is the difference between 150 and 600? So yes, you have your starting point, but what jump did you make? What jump did you make to get to actually the 600 centimeters? And so to find that out, you look at the difference and we subtract to get the difference. Now this is another strategy. You could now subtract to get your difference. And the difference is 450 centimeters. But is that the answer? No, that's telling you the difference in height. Remember, the question asks for you to find out how many days would it take the baby giraffe to grow this total 450 centimeters. And so you could ask yourself the question now, how many sets of 30 centimeters can we get from the 450? And the reason for that is that the baby giraffe grows at a rate of 30 centimeters per day, which means each day. So how could we find this out? Anybody could tell me what we could do to find out how many sets of 30 centimeters we can get from 450 centimeters? You can go right ahead and type it in the chat. Go right ahead and type it in the chat. Awesome, Sarah. Sarah said division. Chantel is saying division also. Kalisa, and the chat is just burning up. So there we have it. We could divide, and when we divide, we would get 30 centimeters. 450 divided by 30 is equal to 15. Let me correct that. 15 centimeters. And finally, here, I know I said 15 centimeters. Let's correct that. 15 days old. So over a 15-day period, the giraffe grew 450 centimeters, and 450 centimeters added to the 150 centimeters, which is the height at birth, would give us that 600 centimeters. And that's one way of checking your answer. Notice we pointed out earlier in the processes of doing your quantitative reasoning, you want to check your answer. So you now can do the math. 15 days of 30 centimeters, you can actually multiply to find out what that is. And you would add it to the beginning or the starting height at birth. All right. So we have 15 days. And most persons type that in the chat. So you are well ahead of the ball game. So let's move on to our third question. So here is question 3. And guess what? Which of the following will change? Get ready to share with me. At this point, I'm going to give somebody a chance to share with me. So listen out for it. So again, look at it. First of all, we want to look at the information that was given. By now, you should get the drill. Any question that you read, you must identify the information given. That shows that you are competent in your quantitative reasoning. So I am going to unmute. I'm going to ask Nekora to unmute and tell us what information is given in this problem. Nekora, you can go ahead and unmute. Nekora, go ahead and talk with me now. Nekora, go ahead. What information is given in this problem and what is it that you're going to use to arrive at your answer?
Miss, his score on the 6th mathematics test was 90.
Awesome. So that's one bit of information. Thank you so much for that, Nekora. His score on the 6th mathematics test was 90. Do we know
90.
anything before that? Anything before that? Any other bit of information before that?
Miss Sam scores the following 1-5 of his mathematics test.
All right. Thank you so much, Nekora. So it also gives you information for the scores on 5 of his math tests. So we're now going to use this to help us. So thanks for sharing, Nekora. So yes, you'll get a chance to interact with me from time to time. So let's go. The question asks, which of the following will change? What math information do we need to solve this problem? What math is it that we're going to do? Can we just look at it and get the answer like that? What do we need to do? I wonder, I'm going to give one other person a chance to tell us what is it that you would do in order to find the answer. All right, let's see some raised hands there. I'm seeing Maddie. Maddie, you may unmute and tell us what you would do to solve the problem. Maddie? All right, not hearing from Maddie. What about Anelia? Anelia, you may unmute and tell us what you would do to solve the problem. Go ahead, Anelia. We're listening, Anelia.
Hello?
Yes, Anelia, we can hear you. Go right ahead. What information do we need to solve this problem? All right, so Anelia seems to be having some challenge there with her mic. Let's go to Jonathan. I'm giving one more person. Jonathan, you may unmute. Go ahead, Jonathan, and share with us.
So the information that was given was what he scored on each test. He scored 95 on the first, 90 on the second, 80 on the third, 90 on the fourth, and 60 on the fifth, and 90 on the sixth.
Awesome. Thank you for that. So how would you solve this problem?
So how you would solve the problem is that you would add 90 to the set. So it's 95, 90, 80, 90, 60, and another 90 now. And then the range and then the range would still stay the same because the highest
stop.
number.
Can you hold a minute there, Jonathan? I noticed you jumped from median and you went over to range and tell us that the range would still be the same. How do you find the range of a set of scores?
You find the largest and lowest number, and then you subtract the lowest number from the largest number.
And what would that be?
35.
Okay, so we have 95 here, and we're taking away 60, which is
60.
the lowest. Awesome.
Yeah.
Thank you. What next? What about the median? How do we find the median?
You organize all of them in order from size, in logical ascending order, and then you find the one in the middle.
Oh, so can you tell us what that would be? Tell us how to order those.
So it's 60, 80, 9. So it's 60, 80, 90, 90, and then 95.
Okay, I noticed. Hold on, Jonathan. I noticed you gave me 3 90s. Let's deal with the set of 5 scores first before we can decide what happens next. Okay, go ahead. And so the final one you said would be 60 here.
Yeah, so 60, 80, 90, 90. And since it is an odd number, you can clearly see that the answer is 90. Yeah, 90.
Awesome. So the median, to find the median, I hope you're listening to Jonathan. You arrange the numbers or the set of scores or the set of data in ascending order. You could arrange it another way. Couldn't I have started with the largest number, Jonathan?
Yes, you could have.
And what's that order called?
That is descending order.
That's descending. Awesome. So we find that the range here, the median rather, is 90. So tell us how you would find the mean.
How would you find the mean? You add them all up, then divide the number of numbers. So since we're doing only the 5 first, that would be 95 plus 90 plus 80 plus 90 plus 60. 90 and 90 is 180, and 180 plus 80 equals 260, and then 260 plus 60 equals 320,
wow,
and then 320
awesome.
plus 95 would equal, let's see,
315. All right,
and then
so we don't need,
315
hold on a minute, Jonathan.
by
Okay, Jonathan, pause right there. I like what you have said. Now, I just want you to tell me now, what's the next thing? After you add them up, what would you do? Are we finished? Are we fine? Okay, are we finished?
Yeah. No, you would have to divide it by 5 since there are 5 numbers. And
so we would now divide it by 5 since there are 5 numbers. Awesome. Now, thank you so much for that. What about the mode? How do we know the mode of a set of data?
The mode of a set of data is the number that occurs most frequent. So the mode of this set would be 90. And if you add the other 90, it would be definitely 90 still.
Oh my goodness. So Jonathan is running ahead of us. So when we look at it, now it says that the 6th score, the score on the 6th mathematics test is 90. When we add 90, would that change the median?
No, it would still be 90.
It would still be 90. Tell me how.
But actually, no, let me rearrange it. So 60.
So while he's doing that, the next 90 would fall somewhere here. And based on what he said, in finding the median, we know that it's that we arrange a set of data in ascending or descending order, and it's the number in the middle. But when we look at this, we have 1, and we can strike them off to see 1 to the right, 1 to the left, then another 1 to the left, and 1 to the right. We are ending up here with 2 numbers in the middle. 2 numbers in the middle. Children, let me just help you as we go along here. When 2 numbers appear in the middle, what we do is to add both of them. And in this case, it is 90 added to 90. We add both of them and divide by 2 because we divide by 2. Let me get that for you. So we now divide it by 2. And what we're seeing is that when we divide, we're still going to end up with 90 in the middle. So we see that the median won't change. What about the range? Looking at it, still we have 95 as the largest and 60 as the smallest. So again, this one won't change. What about the mean, Jonathan? Okay, so what about the mean? Here we added 5 numbers. We're now going to add a 6th number, which is now 90. Okay, so we're going to add 90 to that. So that's now going to be 90 added to what was there before. Are we still going to divide by 5? No, that is changing. So already we are seeing changes in the mean. One more score is added. We are now dividing by 6. So that is going to impact the result that we get for the mean. And of course, as Jonathan said, the mode will not change. That's another 90. So that will not change the mode. So boys and girls, I can see here, we did some working out of math. But in order for you to do the working out of math, we looked at using the math content, the math ideas that you learn to actually arrive at a solution for this problem. So you must pay attention to all those information that is being given so that you can use them. Yes, and reason quantitatively in helping you through the process and use it to help you through the process of arriving at your answer. So from that, we are seeing that the mean is the one that will change. Thank you so much, Jonathan. And I could use Jonathan as an assistant teacher. You did very well with that. Now we're looking at question 4, and you have been doing well so far with your participation in the chat, as well as to open your mic. All right. So remember now, I'm noticing that we have reached our full capacity in the Zoom room here. And so we are live on YouTube. So if you know of your friends who want to join the session, join this webinar, you could share the link with them, or you could ask them to go to YouTube and look for PEP 6 ability test student webinar. So the link is shared in the chat, and you can always copy it and share it with a friend. So let's look at question 4. Here you are given a question. At which point is 4/5 located on the number line below? This time, they have used the diagram. They have given you the diagram, so you don't have to draw any diagram. You want to now look at the information here, and all the information is given. So we want to locate 4/5 on this number line. So boys and girls, one of the things you want to look at is, as I said, the information given and how you can use it. How can we use this? I want you to pay very close attention. On the number line, what are the numbers that you see? So we see numbers on the number line, and we see 0, which is usually our starting point, and we see 1. I wonder, what does that 1 represent? Who would love to share? What do you think that 1 on the number line represents? Let's see if we see any raised hand. I'm seeing Robin Brown. Robin Brown. What does that 1 represent?
The 1 on the number line represents a whole.
Awesome. Thank you so much for that, Robin. 1 whole. Thank you. So that's very important as grade 6 students. Yes, you should know that this 1 here that is shown on this number line represents 1 whole. So how is that going to help us to find 4/5 on the number line? I'm going to ask you a question, and I think since that we're here helping you with quantitative reasoning and going through the process of working out a problem when given, I want to help you to at least know some questions that you can ask yourself whenever you are working with fractions. And the question I want to ask you this afternoon is 4/5 greater than, less than, or equal to a half. As I believe if we can identify a half, or halfway on this number line, we can find 4/5. So is 4/5 less than, greater than, or equal to a half? And I see several raised hands here. And if you have, yes, if you name yourself, your device correctly, I should be able to identify. Omari, I think it's Omari Roberts.
Yes,
Omari
Miss.
Roberts,
Omari
go ahead.
Roberts. 4/5 is
Yes.
less than a half.
Okay, so I hear that it's less than a half. Can you tell us why you say it's less than a half? What does, before you, okay, so Amari Roberts, open your mic and talk with me here. You said 4/5 is less than a half. If you were to represent 4/5 on a diagram, how many parts would the diagram have?
The diagram itself, it would have
Yes.
5 parts.
It would have 5 parts. And how many of that would represent the 4/5? How many of those parts would be 4/5?
4 of the 5.
4 of the 5 parts. I want you to think about what you're saying. 4 of the 5 parts. Is that, okay, so if there are 5 parts, how many would be half of that 5?
Half of the 5.
Yes.
Okay, that would be 3 out of the 5.
3 out of the 5, not quite 3, but a little less than the 3, okay? So it would be like about a 2.5, okay? Now, and even if it's 3, would the 3 parts be more than the 4 parts? Or would the 4 parts be more than the 3 parts?
The 4 parts would be more than the 3 parts.
The 4 parts would be more than the 3 parts. So based on what you're saying, would the 4/5 then be more than or less than a half?
Then it would be more.
It would be more. Thank you so much for that, Omari. And that's why we are having sessions like these to help you improve your reasoning ability. Remember, we're testing your quantitative reasoning, your ability to reason, your ability to use concepts, numbers, and to solve problems. Thank you for that. So I'm going to help you a little here. So thank you for that, Omari. Awesome. So children, a lot of you are not familiar with this, with the number line for fraction. So what you can do, you could actually turn this number line into a rectangle that you're used to. Yes, by just drawing your own rectangle on it. It's your work. You can make, as remember I pointed out, you want to use the most efficient method. Make it manageable for you. And if we're going to be showing 4/5, it means based on what Omari shared with me, the parts must be equal. For fractions, the parts must be equal. And he pointed out earlier that we would have 5 equal parts. 5 equal parts. So how are we going to divide this in this number line here into 5 equal parts? I wonder if I put it here, I'm seeing the first dot, if that would take me there. That's 1. That's 2. Type in the chat and tell me if you think I'm dividing it equally. Go right ahead. You think that would get us the 4/5? Wow, I get a thumbs down. I get a thumbs down, so I better go back because I'm seeing that by the time I get to 5, I would be right here. And that would, of course, be showing me 5 out of 5 there, and already I have reached, and I'm not there at the whole, which is right here. So here, if I'm representing the whole as fifths, it would be 5/5. So that's where I want to go. So thank you for sharing in the chat. So I know I have to go back and do my drawing again. So here we go. Here I have my rectangle and 5 equal parts. I see some hands raised. Can I tell you something? We are going to divide it. I wonder how many dots are going to be there. So let's see if we move on to the second one. So that's now 1, that's 1. Let's try this one. That's 2. Are they looking even? Yes, looking a little bit even. All right, so that's 1. That's, yes. So we're going to name them as we go along. And here we have another one and the final one, which is at the end here. Awesome. So they kind of look even to me. They look equal. So that's 5 equal parts there. And if we were to name them, the first one would be 1/5. The second one, based on the fraction that we're working with, would be 2/5. And this would be 3/5. And here we have our 4/5. Awesome. So right there, you would have worked out where 4/5 would have been on the diagram. And this one hole here is 5/5. Awesome. Thank you so much for helping me out. Amari, thanks for sharing and for helping out. So that's one way. And there are other strategies that you could actually use. As a matter of fact, I have been sharing with you from evening that you don't have to use one way to arrive at the answer. It depends on your understanding of the problem. And so we looked at the information that was given and we determined the map that we should use, and we use the diagram. But let me say this also, you could have looked at the dots that are there and also use that. So that's our starting point at 0. And when we move on, we're seeing that we're jumping 1 and 2, and we're using the intervals here, and 3 and 4 and 5 and 6 and 7 and 8 and 9 and 10. So we're seeing here that we have 10 intervals. And again, we could write that as a fraction. So 10 out of 10 would represent the whole here. And boys and girls, as I said, just using up the ideas that you know. So where would 4/5 be? You could look at it and say, what is the relationship between fifths and tenths? And there, I know that you have used equivalent fraction. We could use our equivalent fractions to help us and find where 4/5 is. This would be, based on what we're seeing, the relationship between 5 and 10, or 5th and 10th, is that we're multiplying the number 5 by 2, and that gives us 10. So I'm writing it here, and we're to do the same thing to our numerator. Whatever you do to the numerator, you do the same thing to the, let me say that again, whatever you do to the denominator, you do the same thing to the numerator once you are finding equivalent fractions. And so it's 4 multiplied by 2 now gives us 8. But this is telling me that 8/10, which is 8 out of the 10 intervals, would be my 4/5. That's 1, 2, 3, 4, 5, 6, 7, 8, which would now land me right at R. So boys and girls, strategies, lots of strategies to help you with your quantitative reasoning coming out of our webinar here, and the answer is R. I want to say to you that you have been good sports, but coming up to take you to the rest of this presentation is Coach Carol Harris. So we will receive her now as she moves on to question 5. Thanks, Ms. Harris.
Thank you very much, Mrs. Williams. Good afternoon, boys and girls. We're going to pick up from where Mrs. Williams left off, and we're going to question number 5. Now, let's see what question number 5 tells us. Question number 5 says to us that we have a diagram showing 2 squares which are joined to form a rectangle without overlapping. Each square is 8 centimeters long on each side. And it also goes on to say to us, we are to use this information to determine the distance between A, the center of one of the squares, which is the left square, and B, a point on one of the lines of the second square. Now we know by now that we need to be looking out for what information have we been given. So can I see a couple persons telling me some of the things that they see that they've been given? What are some of the things you think have been given to you in this question? I don't want the answer. Remember, we have a process. So we have two squares joined without overlapping. Anything else you've been told? The length of each square, Zoe, thank you. That the length of each square is 8. Thank you, Abigail and Adrano. That each square has a length of 8 centimeters. Excellent. So that's two things that we've been given. Now, where is A? That's something else that's given. A is where? In the center of the left square. All right. So we want to look at what is given. What math will I need now? They've told me about the things. They've told me about the shapes. It's a square. They've told me the length of the square, but I need to know something. What math do you think you need to know in order to answer this question? Somebody tells me perimeter. Okay, perimeter. Did they ask me anything about the distance around the square? So let's take the question now. So read your question carefully, because that happens sometimes with us. We are accustomed to seeing a particular way the question looks, and then we go straight into what we think the answer is. So let's look at what the question actually asks us. Here's the information given. What did they ask us to do? The question asks us to find not area, not perimeter. It asks us to determine the distance between A and B. They're asking us to find a distance. Thank you. Thank you, Isaac Arkenia. Thank you for that. We want to find the distance between A and B. So let's move on to see how we could find the distance between A and B. I see some persons telling me the answer, but remember, we're looking at our process. We're asked to find a distance. Excellent. So though perimeter is a distance as well, we're not being asked to find the perimeter. So how will we find that distance? Let's look at that together. We know already, because they told us about some properties of this shape. They told us that the center A is at the center of the square. So let's highlight where that A is in relation to the others, to the side of its square. It is going to be what? It's going to be from 4 centimeters from A to the square. So, Mrs. Williams, remember, could you just show our participants from your screen for me, please? We just want to help those who are not able to see it, visualize it. Could you just please show them annotate the screen for me, please, to just show them the distance from A to one side of the square and then the other one. So can you just use a pen to highlight that for me, please? The two distances that were being shown in this diagram. Great. So from A to that part of my square is going to be what length? Somebody type in the chat and tell me what length that distance is. Good. It will be 4. Thank you. But what about the other part? That other part is going to be, that's 4. And the other part is going to be 8. So what would the total length be? I see somebody had said addition earlier on, the total length will be 12 because they asked me for the distance between. It's not 32. We did not ask us for perimeter. Remember where to look out for what the question asks. Don't just jump and say, oh, this is a perimeter question. No, read your question carefully to ensure you're clear on what the question asks. Wow, I just saw an interesting approach. Someone just said they would take 4 from 16. Lovely. Excellent thinking. I didn't get to see who that was because the chat was just blazing up. So good. I love that word. Don't be impulsive. Excellent choice of words there. Read your question carefully. Follow your process. Look for what is given. Look for what is asked. And think about what math you will need in order to get from what you were given to answer what you were asked. Make sure you do that. So I see many of you showing me that it's 12. So our correct response will be option C, which is 12. I love that approach though. Let me see if we have the time to go through that. Mrs. Williams, could you just quickly, let's just help them to see how you could make it 16. So you could have taken the entire length of both of them, being 8 plus 8. So the whole length could have been 8 plus 8, which is 16. But I'm not taking the entire thing. I'm taking off a piece. I'm taking off that part. No, just a little part that is 8 and 8. But I didn't take the entire thing, did I? I took off a piece. I took off a half of one of them, which would be 4. So I could also take 4 from 16, giving me 12. Excellent. All right. Thank you. So let's move on to our next question, question number 6. In question 6, so we'll clear the drawings quickly in a while. In question 6, we have a 100 chart. Now, or a part of a 100 chart, I should say. Now, in this chart, we are being asked to find what number is marked with a question, is the smiley face. All right. Now, I see some people jumping ahead and telling me 88, 88, 88. All righty, I hear some 88s coming in fast and furious. 88 is coming in fast and furious. So, all right, I'm gonna take a quick minute, just a quick minute I'm gonna take, and I'm going to ask, I see Maddie. I see, so what kind of, based on what Mrs. Williams said earlier on about some of the categories in which our quantitative reasoning will take us, what category do you think we're looking at in this case? Are we talking about comparing quantities? Are we talking about estimation? What are we looking at here? Can someone type in the chat and tell me what aspect, which category are we looking? I saw patterns, which I guess was patterns. Good. We're looking at patterns, yes. And we're also looking at, there's something else we could look at as well. It's primarily patterns, and our pattern, as Mr. Levi said, is adding by 10. Mr. Levi, open your mic for me. You've been wanting to say something from so long. Mr. Levi, tell me which part of the, open your mic, Mr. Levi, and tell me which part of the chart are you using to look for the adding by 10? Go ahead, Mr. Levi, open your mic and tell me. Oh, you can't say. Oh, go ahead and tell me what part you told me about adding by 10. Didn't you earlier, Mr. Levi? Tell me a bit. Which part of the chart are you using when you add by 10? Are you which way are you going? Which way along the chart are you going?
When you're going vertically, you
vertically, which is from top to bottom or from bottom up. We're changing by 10. Thank you. So vertical are the columns. Thank you, Mr. Levi. When I go by columns, I'm going by 10. Now, since so many persons are telling me 88, all righty, Rajon, tell me how you got that 88. Open your mic, Rajon, quickly, and tell me how you got that 88. All right, Rajon, you're taking a bit of a while and we're up against the clock. Let me see who else has raised their hand and I could give them a chance to speak. Since we're against the clock, but I want to make you, I know it's a webinar, but as much as I can let you get involved, I would love to let you get involved. Vicky, go ahead and tell me, how would you get the 88?
You will have to add 10.
To? What am I adding 10 to? What would you be adding? I don't see anything above the smiley face, so what would I be adding 10 to?
You're gonna add 78.
All right. Where am I getting 78 from though? Where in
Because
the
first from 74, you're gonna add 1, which is 75.
Okay, fine. So I'm gonna be getting 75 and then 77 and then 78. Fine. I agree with you wholeheartedly. Pardon me. So could someone tell me another way I could have gotten my 88? Could I take it from my 90s row? Who would like to tell me how I could get it from my 90s row? Rhea. Rhea, you ready to tell me? All right. Go ahead, Schroeter. You were asking to tell me quickly. All right, I'm not hearing from Schroeter. Let's look at it together then. Suppose I had said to myself that on my bottom row, I have 98 in this position. Isn't that so? 98 is in this position. Are we all in agreement with that? Which would mean the one above 98 must be 10 less. This time now I must subtract. This time I won't add. When I'm going up, I subtract, but when I'm coming down, I add. Great. If I were going left, so suppose I had, just for argument's sake, before we move on, suppose I had 105 here. Could you replace my 98 with 105, please, Mrs. Williams? Great. 105, because okay, Diamond, I see where you can't unmute. Sorry about that. Suppose it were 105 and not 98. What would be in the part marked? Put an X underneath where the 76 is, please, miss. Let's see if we can quickly do that. If I had asked to put an X here under the 76, could someone tell me what would be that X if I had 105? Give you a little time to think. Let's see which participants raise their hands. Somebody tells me 103, but I don't agree with that. Go ahead, Kalissa, what would you do? What would the X be in this case? Be prepared to tell me what to be. If I had 105, what would my X be? Kalissa?
88, miss.
We've passed the smiley face. I'm giving you a chance to try another one, because some of you were here at the last workshop, so you know what it is. So I've changed my number this time. I see 5 participants have raised their hands. Let me see who are the persons who have raised their hands. And let me see if I could allow someone quickly, before we move on, to tell me what you think it could be. Let me allow Jacina. Jacina, could you tell me what the X would be if I had 105 in that position? Jacina, go ahead. Jacina. I see some persons typing this. Yes, go ahead.
Miss, if you had 105, you would take away 105 by 10, and you will get 95.
So I'm asking you what the X would be. What would our X be?
Miss, 99.
What would the X be, Kalissa?
99, miss.
How comes the X got bigger? Think about that. Could the X be bigger and it's to the left?
No, miss.
It would be what then? What should I do to get the X? Should I be adding to 95 or taking away from 95?
Miss, taking away, miss.
Great. So what would my X be, Kalissa?
86.
See what got you thinking this time? Anyone wants to help out, Kalissa? All right. I would take away Fitzray. Tell me why you got 93. Listen out, Kalissa. Fitzray, why would you say 93? Tell us quickly. Can you unmute Fitzray? All right, let me just add in for Fitzray. So Fitzray rightly said 93. So if 95 is at the smiley face, remember, as we go left, we would be subtracting. We take away 1 each time. So 94 would be to the left of 95. And then to the left of 94 would be 93. So the X would be a 93. Great. You had a good start, Calissa. So just look out for how you would finish it off. You'll be subtracting this time, and we would have a result of 93. Thank you, Mrs. Williams, for that annotation. Great. Let's look at our, so as you all quickly and rightly said, our correct option would have been 88. So we can just go to our correct option. You've looked at the information that was given. We have a 100 chart. We know which way it changes going vertically, which way it changes going horizontally. And we can use that those relationships to determine the missing value that we are asked to find. Great. Okay. Let's see if we can take one. No, it's 10 to, we probably won't be able to take the last question. Let's see if we can quickly take it. Let's see, look at it. We just walk through it. Devontae used the pictograph below to show how much time he spent on homework for various subjects. He spent 2 hours on language arts. What does 1 represent? What does one of our clock faces represent?
Miss Minute. Oh,
Not Calissa. Let me hear from Mr. Aiden this time. All right, I say lots of 30 minutes. All right, let's flip it up a bit. Suppose I said to you, social studies took 90 minutes. Social studies took 90 minutes. All right, before I go to the social studies took 90 minutes, I see lots of people say, God, Joshua, first tell me about your 45. Back up, back up, back up. Whoa, my chat is just blowing up. Oh my goodness. All righty. Half hour, 30 minutes. So who wants to tell me about the language arts? So let's take the language arts quickly. Let's take the language arts quickly. Let me quickly see who politely said, may I? So many persons politely said, may I? Calissa.
Miss.
Diamond, who is that saying? Not Calissa. It was not Calissa Thompson this time. Calissa. All right.
Miss Diamond say may hi to Miss.
So Diamond, can you open your mic now? So who tell him that 1 o'clock is half an hour? They didn't tell me that 1 o'clock is half an hour. Diamond, can you open your mic now? Yes, I can hear you, Diamond. Go ahead.
Miss, for the language arts question, it says that he spent 2 hours on language arts. Miss, it means that, and there are 4 clocks for language arts, Miss. So, Miss, it means that 1 clock is 30 minutes, Miss, because 30 plus 30 is 30 minutes plus 30 minutes is 1 hour. And then that there's 4 of those 30 minutes clocks. So 1 hour and another 30 minutes, that is 1 hour and 30 minutes, plus another 30 minutes is 2 hours, Miss. So that is the answer, 30 minutes.
Okay, so you're saying that it's 4 sets of 30 because it was 2 hours and it takes 4 30s to make 120, which is what is 2 hours. They didn't tell me 120 minutes, but I have to know my relationship between hours and minutes in order to do that.
Miss.
Excellent. Thank you for that very much, Diamond. Thank you for that, Diamond.
You're
that
welcome,
was pretty straightforward. So somebody's also saying I'm finding a quarter of 1 hour and 30 minutes. That's another way of looking at it. So there, as I tell my students, there are many ways to skin a cat. I could have taken it as a quarter of 120, dividing 120 by 4, or as some people would have said, they divided the 2 hours into 2 1-hour slots, and then they went on to find their answer. So what does this 1 clock face represent? You told me already. So it would be 30 minutes. Beautiful. I think you were some of you were repeat attendees today, but I'm glad that you engaged and were able to participate just the same. We're gonna see, let's see if we have any questions from anyone. Before we go to our questions, quickly let us just wrap up. Remember that in your exam, you must make sure that you read your instructions. Remember your quantitative reasoning It's not going to be just coming right in your face. You have to read your instructions carefully, read your question thoroughly, pick out your information given, look out for what they asked you to find, then think about what math will I use to process the information given to get my answer I need. So I need to determine the skills or the processes needed. Am I going to compare quantities? Am I going to add? Am I going to multiply? Am I going to divide? What will I do? Will I need to approximate? Will I need to look at the data and analyze